Welcome back to our Algebra 2 series. Today we are up to section 1.5 where we will be adding and subtracting radical expressions. So here's an example. 3 root 5 plus 4 root 5. Now before your head explodes, I'd like to look at this a slightly different way. Let's look at this equation. A times x plus y times x. We could pretend that x here is the root 5 of the expression. So what does this remind you of? Well, it should remind you of
like terms.
So in this case, we can combine the like term of x to have a plus y as a quantity times x. Remember, going back the other way is what we call distribution. You would distribute the x to both the a and the y in the expression. So we can replace the a and the y with the 3 and the 4. All we're doing is combining like terms. So it's 3 plus 4 as a quantity times root 5. And we end up with 7 root 5. How about this example? We don't have like terms, so we can't do anything yet. The expression needs to be manipulated. So this 4 here should be a clue. This happens to be a nice perfect square. We can pull that out of the equation, and we're left with root x plus 2 root x. And once again, we end up with
like terms.
If it helps, you can pretend that there's an invisible 1 in front of this root x, so we can add the 1 plus 2 and end up with 3 root x. Let's jump over to the whiteboard and do some examples. Okay, we're going to start up here with 3 root 2 plus 4 root 2. So as you can see, we already have
like terms.
So all we need to do is add, combine the like terms. So this ends up being 7 root 2. Okay, let's take another example here of a 19 root x minus 11 root x. Again, we already have
like terms.
So we'll just do the subtraction here. 19 minus 11 equals 8 root x. Okay, we're going to do another one right below here. 5 root 8 plus 15 root 2. Okay, so we don't have the like terms here, but we've got something here that we can manipulate. So let's factor out this root 8. And I'm just going to put it over here. 5 root. Now 8, I'm going to factor into, we'll say, 4 times 2 plus 15 root 2. So you see what's going to happen here. Again, we've got a nice handy perfect square here that's going to come out of this expression. So this will turn into a 2 on the outside, and the 2 times 5 equals 10. So I'm going to show those steps, but in the future I'll probably skip those steps. So we've got a 5 out front. This 4 becomes a 2 because we're taking the square root of the 4. And then we just have root 2 plus 15 root 2. And then we'll do this multiplication. So this is the intermediate step. This is 10 root 2 plus 15 root 2. We end up with 25 root 2. I think we can squeeze in one more down here. Take the square root of 45 minus the square root of 20. Okay, so we're nowhere near like terms, but these need to be manipulated. So let's just start with the first one. Let's factor this 45. 45 is 9 times 5. I'm just going to write that out first. 9 times 5. And we subtract out this 20. And 20 is 4 times 5. So you can kind of see where this is going. So here, again, we have a nice perfect square. Whoops. And this 9 is going to come out and turn to a 3. So we're looking at just this first expression. We've got 3 root 5. That's a 5, sort of. Minus, now look at this expression. This 4, when we pull it out of the square root, becomes a 2. 2 root 5. So 3 root 5 minus 2 root 5. Again, we have
Like terms.
So we end up with just 1 root 5, but you don't need to write the 1, so you could just write square root of 5. All right, let's clean this off and do some more complicated problems. All right, let's get crazy now. Not crazy, but 9 root 8 minus the square root of 72 plus the square root of 98. Okay, so we have 3 things here, but the same process will apply. And we'll just have to manipulate these until we end up with some, like terms. So 9 root 8. I'm just going to write this out as, I'm going to give myself a little more space. 9 root, so what's 8? 2 times 4 times 2. Let's just write it out. 2. I'm going to factor all these. 2 times 2 times 2. I'm going to do a prime factorization of each of these to see what kind of like terms we end up with. So if I were to prime factorize 72, so this is 36 times 2, and 36 is 6, and 6 is 6 is 3. So what I'm going to do is just break all that out. So do a prime factorization of 72. You get 2 times 2 times 2 times 3 times 3, right? 2 times 3 is 6. 2 times 3 is 6. It's 36 times 2. Yep, okay. And then we need to do 98. So 98 is 49 times 2. And 49 is 7, so it's going to be 2 times 7 times 7. Okay, so let's look for things that are squared. Here's 2 squared. 2 times 2 is 2 squared. This is 2 squared, 3 squared, and 7 squared. So in this next line, I'm going to pull out the squares. So we've got 9. I'm going to pull out a 2, because 2 times 2 is 4, or 2 squared. Now when this comes out, these 2 become a 2 on the outside. So I'm going to skip that intermediate step where I write the 9 and I write the 2 that we pulled out. I'm just going to multiply right now. So this 2 comes out to be a 2 out front. 2 times 9 is 18 root 2 minus. So here we have another 2 that can come out because these will combine outside as a 2. And these 3's will combine together, 9. But we take the square root of 9 and it becomes a 3. So we're pulling out a 2. Actually, let's put a little line underneath them. I pulled this out. I'm going to pull this out. I'm going to pull this out. So this 2 comes out. This 3 comes out. So 2 times 3 is 6. And we're left with root 2. And you can see we're doing the thing here. And then we're going to add, and this 7, right, these pair of 7's, when I take the square root of 7 times 7, it comes out as a 7. So we end up with 7 root 2. So what do we have here? We happen to have
Like terms.
So 18 minus 6 plus 7. So this minus 6 plus 7 is just a root 2. So this ends up being 19 root 2. We've got a little more of a sneaky one here. And let's see if we can fit it in here, hopefully. So we're going to go like this. Take the square root of x cubed minus x squared plus the square root of 4x minus 4. So we are nowhere near like terms. So there needs to be some manipulation here. So let's look at this first one. How can we factor this equation? I'm going to pull a x squared out of both of these, right? So it's opposite of distribution. We're kind of factoring out an x squared. And this is going to fit. We're going to make it fit. We're going to pull out an x squared times x minus 1, right? So if I were to distribute this back, x squared times x gets us x cubed. X squared minus 1 is minus x squared. So all I've done is pull an x squared out of this. And we're going to look at this. And what can we factor? Well, we can factor a 4 out of this one. So I'm going to do that. 4 times x minus 1. So you can see we're getting there. We're doing something. But now we have perfect squares. X squared is a perfect square, and 4 is a perfect square. So this x squared can come out and be just the x on the outside times x minus 1. And this 4 is a perfect square. It can be a 2 on the outside. So 2x minus 1. So now we do have like terms here. Like term being the square root of x minus 1. So we end up with x plus 2 as a quantity times the square root of x minus 1. So when you do a problem like this, make sure that you don't write it x plus 2 square root x minus 1. These don't mean the same thing. This means x plus this whole mess. You have to put these parentheses to make sure you're multiplying this entire entity by the square root of x minus 1. So don't do this. We'll just kind of make it go away. All right, let's clean this off and do one more bonus sneaky problem. All right, I think we've got plenty of space for this one. We're going to take the square root of 3 plus the square root of 1/3. Oh boy. So clearly we don't have like terms. So how can we manipulate this to actually add these two radicals together? So whenever you have a fraction under a radical, the first thing you can do is replace that with, we learned that when you have a fraction like this, it becomes two separate radicals. So I'm just going to rewrite this as root 1 over root 3. And we still have this, root 3 over here. So we've taken this and split it into two separate, radicals as a fraction. But we also learned that fractions don't like to have radicals in the bottom. So we have to kind of rationalize it or clear the fraction, or whatever you want to call it, to make this happy and not have this weird thing in the bottom. And to do that, we take this and we multiply, this entity by 1. We're allowed to multiply anything by 1. So we're going to take this thing and make a fraction of it that equals 1. So now we can multiply this across, and I'm just looking at this here. We're going to come back to this root 3 in a minute here. All right, so remember, we can just multiply straight across, and this equals, and I'll put the root 3 here. I'm just kind of carrying this guy over, plus, so 1 times 3, this ends up being, and again, when you multiply two radicals, you multiply their inside. So 1 times 3 is 3, and this ends up being, root 9. And we did this, so we end up with a nice, happy, perfect square here. We're going to go like this. We're going to rewrite that root 3 that keeps coming along for the ride. This ends up being root 3 over 3. Right, so square root of 9 becomes 3. And here's another sneaky step to this one. So we sort of have like terms, but it's not super obvious. So what I'm going to do is I'm going to, again, rewrite this equation. I got enough room here? Probably. Yeah. So I'm going to write this as, a magical 1 root 3. And this is really 1/3 root 3, right? Oops, 1/3 root 3. Root 3 over 3 is the same as 1/3. So now we have a like term of root 3, 1 plus 1/3. So the best way to write this whole mess, I'll just kind of slide it over here. So 1 is 3 over 3, and this is 1 over 3. So we end up with 4/3 root 3. So there's a lot of sneakiness going on here. So let's just go over this real quick one more time. When we have the fraction inside the radical, we split it, right, into two. Ignore that for a second. Into two radicals as a fraction. But then we found out that we don't like having a radical in the denominator, so we're going to multiply this entity by 1. It's a 1 made of the same thing on top and bottom that happens to match this thing. We multiply it across. Square root of 1 times the square root of 3 is the square root of 1 times 3, so we end up with this. We multiply these two across. 3 times 3 is 9. We end up with the square root of 9. The 9 becomes a 3, right? We're taking this fraction and simplifying it here. And to get from this step to this step, you have to recognize that this root 3 over 3 is the same thing as 1/3 times the square root of 3. That gets you to a common, like term. And you can kind of see that we were close here. We had to shift this to this to make these like terms. We know this is just 1 root 3 plus 1/3 root 3, so it's 1 and 1/3, or really 4/3 root 3. That's it for today. We'll see you next time.
Like terms.